Today we're learning about special products, and our essential question that we're going to think about as we're learning these is, why do special products have their own rules? So the first special product is what are called conjugates, and if you take a look at what we have set up here, you'll notice they both have an M and a 3, but in one of them the 3 is opposite. So this is what conjugates are. We're going to start by multiplying these just like we learned to do with our regular binomials, and we're going to see what happens. So m times m gives us m squared. We have m times negative 3, which is negative 3m. Distributing our positive 3 to the m, now we have a positive 3m. And finally, distributing our positive 3 to our negative 3, we have negative 9. We also have like terms on this one. So combining our like terms, first of all, we have our m squared, and then negative 3m plus 3m cancel because they're opposites, so we're left at the minus 9. Let's see what happens on the next one, and then we'll talk about the shortcut for conjugates. Starting off again with our distribution, we're going to distribute that 2g to 2g, multiply the coefficients as well as the variable. So 2 times 2 gives us 4, and g times g gives us g squared. 2g times 7 is a positive 14g. The 2 times 7 gives us the 14. Doing that again, the negative 7 times 2 gives us a negative 14g. And the negative 7 times positive 7 gives us a negative 49. Combining our like terms and simplifying this further, our first term is not a like term because that has a square, and the other two terms have regular g's. Once again, these cancel. Positive 14g minus 14g adds to 0, which means we don't have to write that result, and the minus 49. So this only works with conjugates, so I don't want you shortcutting when you see regular polynomials. But if you recognize the conjugates, to get the answer in simplest form right away, you simply take your first term times itself. That's how we got the 4g squared. And the negative 7 times positive 7 is how we got the negative 49. The middle two terms ended up canceling. Our next type of special product is squaring binomials. So if you notice off in the right-hand column, I have a note for you to think about, what does it mean to square something? Because there's an error that students tend to make on this one when they forget what it means to square. And what it means is to multiply something by itself. So what I want you to do is write this out the long way. If you do not write this out the long way, you will make a mistake. Lots and lots of students make mistakes on this one. And I'll show you the mistake in the error analysis on the next page. So we've got a times a is a squared. A times 9 is a positive 9a. 9 times a is another positive 9a. And 9 times 9 is 81. So if you notice this time, the middle terms look the same like they did on the last one, but they have the same sign. So instead of canceling, we add them together. So we've got our a squared, the 9a plus 9a gives us a total of 18a, plus 81. One more time with our squaring example. Again, writing this out the long way, multiplying our 4 minus g by itself, and then we're going to use our double distribution. We get 4 times 4 is 16. 4 times negative g is negative 4g. Negative g times 4 is another negative 4g. And negative g times negative g is positive g squared. Combining our like terms and writing this in standard form, our g squared ended up on the end this time, so I'm going to move that to the beginning. Again, we've got two of the same term in the middle, and they have the same sign, so they do not cancel. So we have a total of negative 8 g's, and then our plus 16. So as promised, I see lots of mistakes on the squaring binomials one, So I'm going to show you the most common mistake that I see, and hopefully you will avoid this in the future. So we're taking y minus 5 and squaring it. So I'm going to distribute my square to both pieces. Y squared is y squared minus 5 squared is 25. Hopefully after seeing squaring the correct way, you can catch the error on this pretty quickly.